Good morning, friends. This is Professor Chaubey's physics class. Today we will have some problems in the beginning belonging to nuclear physics, radioactivity, modern physics, and then we may discuss some topics also. So this is under the heading Physics Made Simplest for CBSE, for NEET and for G students. So dear friends, I will write now problems and then I will explain their solutions. The fission of a heavy nucleus The fission of a heavy nucleus gives in general two smaller nuclei. Two or three neutrons, some beta particles, some beta particles, and some gamma radiations. It is always true that the nuclei produced nuclei produced have a total rest mass that is greater than that of the original nucleus. Have large kinetic energy that carry off the greater part of the energy released. Have large kinetic energies that carry off the greater energies that have larger kinetic energies that carry off the greater part that carry out the greater part of the energy released. C travel in exactly opposite directions. D have neutron to proton ratio that are too low for stability. So dear friends, we have now this question which is from fission. The fission of a heavy nucleus gives in general two smaller nuclei, 2 or 3 neutrons, some beta particles and some gamma radiation. It is always true that the nuclei produce. So I have one question and there are 4 options. You know the fission, of uranium fission, we get 2 heavy fragments, medium weight. From the heavy weight fission of uranium, we get medium weight, like iron, middle weight, around 56 and 70, 60 like that. So that is the charge around that. So fission of this will give 2 medium weight fission fragments plus neutrons which are more than 1, means 2 neutron or 3 neutron, and beta particles and gamma radiations. This is what the fission is described by these. But now questions are, there are 4 parts of this. In the fission, it is always true that nuclei produced, those 2 nuclei, medium weight nuclei, which are produced, which is correct now out of these 4? A, have a total rest mass that is the greater than the original nucleus. Well, this is ridiculous. How it is possible that the mass produced is more than the initial? It is possible that mass produced may be less, but not the larger, because larger from where the mass is converting. It means energy is converted into mass. We don't have energy in the beginning, so how the mass of the fragments will be more than the initial mass? It is not possible. It is possible that mass may be less. So this thing, this may not be correct. Now I come to have NP ratio low, so no stability. NP ratio means neutron to proton. If neutron is less, proton is large, well, Coulomb repulsion will be more. So the nucleus will be breaking, they are going apart, far apart, because protons are repelling. So a smaller neutron-proton ratio, if that is there, the system will not be stable, but we have stable heavy fragments which are moving with the kinetic energy, and their beta particles and gamma and neutrons, etc. So have NP ratio low, no stability, while fission fragments are stable. and they are moving with kinetic energy and producing lot of heat. So this thing also is not true. And travel exactly in the opposite direction. Why they should travel opposite direction exactly? That particles after any interaction travel just opposite to each other to conserve the momentum. But here there are many particles going in different directions. It is not a controlled fission. Fission is human produce fission in the reactor that can be controlled. But when fission starts, it is not controlled. So it is moving in all directions because energy produced now, particles are moving all directions, total momentum will be conserved, no doubt. But why the fission fragments should move opposite to each other? Because there are other particles also for the conservation of momentum. So they can go in any direction. So this thing, that travel exactly in the opposite direction, this may also not be true. Now I discuss point B. Have large kinetic energies that carry off the greater part of the energy release. Yeah, this looks to be true because correct. Have large, they will have kinetic energy large because in each fission of one uranium, around 200 MeV energy is released. So 200 MeV energy mostly associated with the fission fragments. Very, very small in the neutron with the neutron and beta particles. That few MeV, maybe total 4 or 5 MeV. But the large energy, around 195 or 190, you can say MeV energy is associated with the two fission fragments in one uranium fission. So whatever two medium-weight fission fragments are produced, they move with a huge kinetic energy. So have large kinetic energies that carry off the greater part of the energy released. Yes, both of the fission fragments carry larger energy, which is released in the fission. And very small, I told you, a very small, around 5 MeV energy is taken by the beta particles, gamma radiations and neutrons. And most of the energy, around 195 MeV is taken by fission fragments. So this is correct. This looks to be correct. In this way, this question is done like that. The answer of this question will be B part. So I have explained you in details the answer of this part, this question. Now let us move some other questions and we will discuss like this so that you can judge yourself the answer. But why this answer, I will explain you. Remember that I will now be having continuous physics classes. Last time I was having some problem, health problem. So I stopped for some time. Now I am going to take continuous, most of the continuous physics classes. So we will now see some other thing. The activity of a radioactive sample is 1.6 curie. The activity of a radioactive sample is 1.6 curie. Half-life is 2.5 days. Its activity after 10 days will be 0.8, 0.4, 0.8 curie. A and B is 0.4 curie. C is 0.1, 0.1, 0.1 curie, or D is 0.01 curie. Well, I have a very small question. The activity of a radioactive sample. You know, radioactive sample is decaying. Its number of radiations coming out per second, that disintegration rate, its activity decreases. Half-life, it depends upon the half-life. If half-life is small, it will have fast decay. Decay probability will be more. If the half-life is large, decay probability will be less. So, half-life is 2.5 days. Well, to solve this, you use the simple radioactive decay equation that N is equal to N naught e to power minus lambda t, where lambda is 0.693 upon half-life, t half. So this is the equation, mathematical equation of decay rate. N is equal to N naught e to power minus lambda t, where lambda, you know, decay constant, and t half is the half-life. So this, you can put here the half-life, just 2.5 days. You can find the initial is 1.6 curie. You will get the mathematical solution. But physically, just we check. You see, half-life means after 2.5 days, it will be half. Here answer is 0.8. So 0.8 is the answer, that is the 1.6, half of this. So that will be just after half-life. So after 2.5 days, this may be like this. But they are asking that its half-life is this. So its activity after 10 days, we have to get 10 days. But this will be just after half-life. So this obvious, just by judging, this answer may not be correct. And then 0.4. 0.4 is further half of this. It means 2 half-life. So friends, you can solve this easily using this equation, that is the half-life. You put the half-life at 2.5 days and you will get the answer. But I am saying this, without solving this, from the common sense, can you guess what may be the answer? From the common sense. Forget the equation. Because this 0.8 cannot be correct. Because 1.6 it is half, so it is only one half-life. 0.4 cannot be correct. Because 0.4 is just one more half-life. But this is 10 days. 2.5 into 4. So this also cannot be the correct answer. Because it is 10 days. It will be after 2.5 days. It will be after 5 days. So this also cannot be correct. This is from the common sense. Well, this is too low because 0.4 and then next one more half-life will be 0.2, then next half-life will be 0.1. So this is too less. This cannot be correct. This, you see, obviously, this is one half-life, 2.5 days, this is 5 days, and then half of this 0.2 will be after 7.5 days. The half of that means 0.1 will be after 10 days. So this is correct answer. Well, this, without doing these calculations, this can be, the answer of this can be judged, that the answer of this question will be C part, that activity of the radioactive substance after 10 days, where half-life is 2.5 days, will be 0.1. It is the 4 half-life, because one half-life 2.5 days, 0.8. 5 days, 0.4. 7.5 days, 0.2. and then 10 days 0.1. So simple. So this is I think very easy. You can do very easily this question and the solution of this question. Now we talk something else. Next, maybe some question. The rest mass of a neutron is equivalent to an energy of this. The rest mass of a neutron. What is the meaning of A? The rest mass of a neutron is equivalent to an energy of an energy of how much? 1876 MeV. That of a proton to 939 MeV. MeV, that of a proton of 930 MeV. MeV and that of a neutron of 940 MeV. The rest mass of a neutron is an equivalent to an energy this, that of a proton of this, and that of a neutron that of about 940 MeV. A neutron may disintegrate to a proton and a neutron. The neutron may disintegrate to a neutron and a proton if A emits an X-ray photon energy, if emits an X-ray photon of energy 2 MeV. X-ray photon of 2 MeV energy captures X-ray photon of 2 MeV energy, emits X-ray photon of 3 MeV energy, and captures X-ray photograph. Well, you see this question. What is the question? Question is the rest mass of a deuteron. Deuteron is equivalent to, deuteron is a combination of one neutron and one proton. So deuteron rest mass equivalent to 1876 MeV. Well, proton rest mass 939, neutron slightly more 940. That deuteron may disintegrate. You see, deuteron disintegrates to proton plus neutron. But energy mass of this side, energy of this side must be equal. So deuteron is 1876. Proton, neutron both together. And then see what the difference is here. Proton and neutron. P plus N. You have to add this. 940, 939. 939, 940. It is 1879 MeV. We have deuteron 1876. So the energy equivalence 1876. This side we have 1879. This disintegrates to proton neutron. And remember that energy is 1876. We require 1879. If deuteron emits X-ray, if it emits X-ray, means X-ray goes out 2 MeV, then it should be only 1874. It is not correct. So this is obviously not correct. Captures, if it captures 1876, captures 2 MeV, it becomes 1878. But it is 1879. So obviously this is also not correct. It emits X-ray 3 MeV. If it emits X-ray of 3 MeV, here it will be 1873, which is not correct. So this cannot be correct. Now the captures X-ray photon of 3 MeV energy. Well, if this captures 3 MeV X-ray, well, this will be 1876 plus 3, 1879. So energy will be conserved, both sides. So the answer that deuteron disintegrates to proton neutron by capturing 3 MeV X-ray, means 3 MeV energy. That is called disintegrations, photo disintegrations of deuteron, means photon of 3 MeV is absorbed by deuteron, then because it is bound, its binding energy is 2.22 MeV. So you want to break the deuteron, you have to pump energy, you have to supply energy. Deuteron cannot disintegrate by itself. It is not in nature as deuteron disintegrates. Deuteron is a stable particle. Binding energy about 2.22 MeV. So, if you want to break a deuteron, means into proton, neutron, energy will not be evolved. Energy will be absorbed so that they disintegrate. Wow, how much energy? They are supplying 3 MeV. So 3 MeV energy, then both sides, left hand side, right hand side equations, conserve energy is conserved. So deuteron can disintegrate to its component, its constituents, one proton and one neutron, provided a 3 MeV energy is pumped into deuteron. So this part of the answer is obviously correct. And others, all three parts are wrong. In this way, you can judge. your knowledge, because neutron is made of neutron proton. So the two sides of energy must be conserved, left hand side and right hand side. Left hand side is 1876, right hand side is 1879. So it will be equal if 3 MeV energy is given to neutron, means it absorbs X-ray of 3 MeV energy. That is the correct answer. Okay, let us go to some new question. A newly prepared radioactive nuclide has a decay constant lambda of 10 to the power minus 6 per second. What is the approximate half-life? What is the approximate half-life of nuclide? What is the half-life? Answers are given 1 hour, B is 1 day, C 1 week, D 1 month. When you see decay constant lambda is 10 to the power minus 6. 10 to the power minus 6, that is the decay constant. Well, you can put half-life, newly prepared radionuclide has decay constant lambda this much. So what is the half-life? You know, lambda is 0.693 upon half-life, T half. So T half-life is 0.693 upon lambda. Well, that you can guess, you can calculate within 1 minute. 0.693 upon lambda means 10 to the power minus 6. So 10 to the power 6 seconds. This is the answer. You can convert into the days, hour. Well, 1 hour is not having so many seconds. So obviously this is not correct. 1 day also, you know, 24 hours. So how many seconds are there? So that also not. 1 month is very large. You can get 30 into 24 into 60 into 60, obviously. So this is large. This is not possible. So just judge the answer from your common sense. This appears to be correct answer. 1 week. Because 1 day is 24 hours. Into 24 hours 1 day, into 60 minutes, into 60 seconds. So this is the 1 day. This not possible, this not possible, because answer is this much. Answer is 693,111. 693,000. And obviously this is not possible. This is, you can see, and this is very large. So this correct answer is the C part in 1 week, because this into 1 week means 7. You can get the answer will be this. So this was very simple answer, just simple small calculations. But from common sense also, without calculations you can judge, because 1 month is too large, 1 day is too small. So obviously 1 hour is further very small. So obviously the answer will be 1 week. Common sense answer, 1 week. The half-life of a certain radioactive isotope is 32 hours. The half-life of a radioactive element is 32 hours. What fraction of a sample would remain after 16 hours? What fraction would remain after 16 hours? Well, the answers I give: 0.25 B, 0.71 C, 0.29 D, 0.75. 16 hours is the 32 hours is the half-life. So 16 hour decay means it is even not half-life. So what that, if half-life 32 hours, half-life after 32 it will be half. So there is no half. Remaining 0.75, when 3/4 remaining, only 1/4 decay. So just you can find out n is equal to n naught e to power minus lambda t. So after 32 hours, so n remaining, n over n naught is e to power minus lambda t. Lambda e to power minus 0.693 upon half-life 32 and t. So what n over n naught? After t is 16 hours, that is e minus 0.693 into 16 over 32. So this 2, and this is e to power minus 0. E to power this. So just you can find out. Well, they say the answer is, just you have to find out the B part. Because this is too much decay. This is also too much decay. This is less decay. We have to go to years. Next, I think that I should have some more problems. Well, a sample of radioactive element has mass 10 gram. A sample of radioactive element has mass where 10 gram. Ten gram is the mass at T is equal to 0 initially. The approximate mass of this element in the sample after 2 mean lives. After 2 mean lives, mass. Calculate. After 10 gram is at T is equal to 0. After 2 mean life, how much it will be there? A 0.135, 2.5, 1.35, C 0.0135, D 2.5. Well, this is just common sense also. 2 mean life decay after 1 mean life and after 2 mean life. So what remaining? What will be there after? It is started from, it was 10 gram, yeah. So you can get n is equal to n naught e to power minus lambda. You know, lambda is 1 over tau, mean life, t. So this becomes equal to n naught e to power minus, t is 2 half-life, 2 mean life. So 2 tau and divide by tau. So n over n naught is equal to e to power minus 2. Just you can see. Or if you have idea of what the exponential value, you can get. But you have to get e to power minus 2 from the table, or just you get from the common sense also. From 10 it comes down, n over n naught, n was 10. Oh, sorry, n naught was 10. So after 2 mean life, n naught was 10. So n will be 10 into e to power minus 2. Well, this is too small. And this has too large value. Because 10 gram after half-life becomes 5, after one more half-life 2.5. So this is 2 half-life. But it is 2 mean life, so this cannot be there. And this is also too small. It looks that this may be correct because after 2 half-life it becomes 2.5. After 2 half-life. But they are saying after 2 mean life. So this was very small, this was Large, oh, this is large because 2.5 is after 2 half-life, but after 2 mean life, so after this decreasing, this will be correct answer. This is too small. So obvious, otherwise you get from mathematical calculations. But from the common sense, it appears that this is the correct answer. So that is the common sense. Most of the questions are answered by the common sense. If you are sharp enough, well, you can get from the common sense. Answers can be available. Okay. After an interval of 1 day, after an interval of 1 day, after an interval of 1 day, 1/16th initial amount of a radioactive material remains. 1/16th of initial amount remains. The half-life is its half-life is 6 hours. B 12 hours. C 1.5 hours. D 3 hours. Well, this you can do by mathematics, otherwise by common sense. Let us get the answer by common sense. In 1 day is half-life. We want 1/16. So 1 day it becomes half. 2 days it becomes 1/4. 4 days becomes, then 3 days becomes further 1/8. 4 days becomes like that decreasing. So we want 1/6. So 1 day half like that. Let us see. 1.5, obviously it cannot be there. 3 hours, this is day, degree, so this obviously is not possible. 3 hours. Interval decays after interval of 1 day, 1 day. 1/16th initial amount of a radioactive material remains. So after 1 hour, initially it was produced, after 1 day it remains like this. So what is the half-life? If after 1 day it remains half-life will be 1 day. But this, or you can get, after 1 day half it becomes like, after 2 days it becomes further. But it is 1/16th of initial, means n is equal to n0/16. So that n over n0 is 1/16 is e to power minus lambda t. 0.693 upon half-life, and time is 1 day. So you will get from this 1 day, or you can get answers are in hour, so you can put 24 hours. From this you find out t half. That 16 is equal to e to power 0.693. 24 divided by t half. So just from this you get the answer. Solve this. But from the common sense I am getting these are large. This is large. From this the answer is 6 hours. You can get from here. e to power 0.69 to 24. Just find out this is 60. ln of this is this. You get 0.693 into 24 t half is ln of 16. And now find out t half. So friends, we will have a short break for some time, and then we will start second session after some time.